Today we're going to talk about factoring special products. We saw these special products in an earlier section of this chapter where we were multiplying binomials together to create these that we're now going to factor back. So the first one we're going to talk about is the difference of two squares, and sometimes we refer to that as the dots. And what that one looks like, as you'll notice, is that we have a squared and a b squared, but we don't have that middle term that we've been seeing in all the other trinomials. So we want to keep that in mind when we're looking for if we see a dots to do. So this one only works when a few things happen. First, there needs to be a difference. So there must be two terms that are being subtracted. It obviously has to be a binomial for two terms because bi means two, and each of the terms must be a perfect square. So we have to keep that in mind. So the first thing that we're going to do is we're going to set up our double bubble. So then we have the two sets of parentheses. One of the binomials is going to be plus or addition, and the other is going to be subtraction. This is what's going to help us get rid of that middle term to cancel out. Then you're going to put the square root of each of the terms separately in the two different sets of parentheses. The square root of a squared would go first, the square root of b squared would go second, and you're going to put those in each of those two parentheses. And lastly, as we always want to do, we want to use FOIL to just check your answer just to make sure it makes sense. So first example. So we look at what we have, an x squared minus 25. So the first thing we have to say is it's a binomial, but we see this little square, which means we might be looking at factoring. There is no greatest common factor between those two terms. And then we also see a difference because we are subtracting the two terms, and each of these, x squared and 25, is a perfect square. So because of those things, I can use what we just talked about up above, or the dots. So to use the dots, we just set up our two parentheses. We're going to have one being added, one being subtracted. Then we look at what is the square root of x squared. Well, that would be x, so those would go in the front terms. What is the square root of 25? And that would be 5. So those go with the second part of each binomial. And again, as a quick check, you might say, if I do my checks here, x times x is going to give me x squared. X times a negative 5 is negative 5x. 5x from the 5 times x, negative 5x and positive 5x cancel, and 5 times a negative 5 is the negative 25. That way we can say this is the factored form of x squared minus 25. Moving on to the second one, we can see again a binomial. It has a difference, and we have to look at those first term and last terms to see if they are both perfect squares. Well, 4y squared is a perfect square because you can say 2 times y and 2 times y. That would give you 4y squared. The second term, 1, is definitely a perfect square because 1 times 1 is 1. So if I just set up my binomials, I'm going to say it's a addition, 1 is subtraction to eliminate that middle term. The first terms in each of these are going to be 2y, and then the last terms will be a 1 to go with the perfect squares at the back. So again, if I'm looking at this, 2y times 2y is 4y squared. If I say 2y times negative 1, that's a negative 2y. If I do 1 times 2y, that's a positive 2y, which causes them to cancel. And then 1 times negative 1 gives me the 1 at the back. So again, that would verify that we have the correct answer for the second one. This next example is just kind of, again, showing you a little bit of a mental math kind of idea. It's not really something you're going to use a whole lot of because if personally I saw this, I would just run it to the calculator and get my answer. But we can use this pattern if we saw something like the 54 squared minus 48 squared. Because they are both squared, that means we have two perfect squares. If it's a minus with no middle term, that means it's the difference of two perfect squares. So we have 1 plus and 1 minus. The square root of 54 squared, remember, would be just 54, so those would go in the front. square root of 48 squared would be 48 in both. So pretty quickly, I can now look at my order of operations and say 54 and 48 is 102. 54 minus 48 is 6. And then when I multiply those two together, I get 612. You can check that on a calculator. And again, we would normally use a calculator for this and really not be looking at doing this, but just goes to show you that we could still do it as long as it's a difference of two perfect squares. That would help us be able to solve that a little more instantly math if we didn't have access to a computer. Then we want to talk about this other one that we saw where we had the perfect squares that were binomials. And if we remember back for a couple of sections ago, we had things that then looked like this one. So x minus 3 squared. So it's not a difference of two squares because it doesn't have x plus 3 and x minus 3. Or this one, which is x plus 3 squared. So this is the square of a binomial, which is a different pattern. And I want you to notice that when we did these, we still had the three terms when we multiplied these back out. So what we're going to do now is instead of having this one that turns into this one, we're going to start here. And if we recognize the pattern, we can go backwards. So let's just go through a few examples. So here we have an example of one of these trinomials. So we don't see a binomial, and we don't see a minus subtraction, so it's definitely not the dots one that we just worked on. But this one does have something that you want to notice. We see an n squared, so perfect square up front, and a plus 16 perfect square at the back. They have to be a plus c value that's a perfect square for this term, this pattern to work, because obviously negative times negative is positive, and also positive times positive is positive. So let's just try. So as I get this one, I'm going to see that I end up with n squared, which would give me the n times the n. The square root of 16 is 4. Now because the b value is a positive 8, that would mean these two would have to be plus. Number one, I need to be able to get the 16 plus times a plus gives me that also positive. They could also both be negatives, but because we're trying to make those two middle terms add up to plus 8n, that would mean they have to be pluses in the between. So again, with my quick FOIL check, I would do n times n is n squared. I would do n times 4 is 4n. 4 times n is another 4n, which does add together to get me the 8n. And then 4 times 4 is 16. So we can simplify this even a little bit further, though, because our better answer here is n plus 4 squared. We have the exact same binomial times itself, so n plus 4 squared would be the answer. So the next one. So again, I can look at this and see I have a perfect square in the front term. I have a perfect square at the back, and again, it's a positive perfect square, so that's important. And so I'm thinking I'm going to be able to use this perfect square pattern. So 4x squared, to take the square root of that, I would get 2x times 2x. 9, the perfect square, would be square root is a 3. Now this time, because this middle term is a negative 12x, these both have to be minus 3's. So as you check this, 2x times 2x, there's your 4x squared. When I go to the middle ones, I get negative 6x. I get another negative 6x. So that's going to now help me see what that middle term, they don't cancel out this time. And then the last one is negative 3 times negative 3, which is a plus 9. Now again, in the dots, those two canceled out. In this case, they're not going to cancel out. They're actually going to give me that middle negative 12x that I was looking for. So that kind of helps me verify that is the correct answer. However, we would want to simplify it to get 2x minus 3 squared to be the final answer. And then lastly here we have when we're solving an equation. So before we were just doing the factoring. Now we're going to put it into an equation to be able to figure it out. Now remember a couple of steps that we've been learning through this chapter. If there's anything on the right-hand side of that equation that's not the 0, you have to bring it over before you can start solving. At this one, we already have it set to 0. The other side's a little bit trickier because we got some fractions involved. But if I look at it really carefully, I see x squared. I see another perfect square here. The perfect square for 1/9 would be 1/3 times 1/3. So I do see two perfect squares, which tells me that I can use this pattern. So at first, let's just change this pattern. I'm going to keep that 0 there. So this would be the square root of x squared is x and an x. Square root of 1/9 is 1/3. And again, because that b value is positive, these both have to be positive. Okay, so we could go the way we've been using the zero product property at this point if you really wanted to. I just want to show you this other one. So if you could have seen this ahead of time to go right to this step, we could solve it still from here. So remember, when I have something squared, to undo that, we would do the square root. That's going to give me x plus 1/3. Square root of 0 is 0. And then I would subtract 1/3 to get x equals negative 1/3. So this one actually only has one root. It only has one solution, x equals negative 3. And lastly, we want to look at this one example with a real life situation. We have a bird that's picked up a golf ball off a golf course, off of somebody's cart maybe, or off the ground, and is now flying away. The functions representing the height of the golf ball, t seconds, so we want to make sure we're using t instead of our x's after it is dropped. So it's going to show us the seconds as the ball is dropped, and we're trying to figure out at the bottom where it hits the top of a tree that is 32 feet tall. After how many seconds does the ball hit the tree? And that's kind of what we're aiming to do here. So first couple of things, we want to kind of think about what this is telling me. So I have y equals 81 minus 16t squared. So right here is the function that they are giving us to determine the height of the ball, which is y's, after t seconds. So what we do know so far is that when the ball hits the top of the tree, my y is now 32. So I'm taking that from here. That's where we want to know when it reaches 32 feet off the ground. The y is your height off the ground. And then I'm going to go and figure out the rest of this formula. Now remember, we have to have 0 on one of the sides. So my first move is to bring over the 32 to get a 0. That's what we're looking for. On the other side, if I subtract 81 and 32, I get 49 minus 16t squared. Now, hopefully, from what we saw earlier in this section, we can see a dots. We can see a perfect square, another perfect square, that are being subtracted. So that is the difference of two squares. The t does not have to be in the front, so we don't need to do that. But from this point here, I can now turn this, if it's the difference of two squares, the square root of 49 is 7. So that's going to be the first term of each binomial. I'm going to do 1 positive, 1 minus. 16t squared, when I take the square root, is 4t. And then, because this is an equation, this is not just do a factoring. I need to use my zero product rule to kind of break apart these two numbers. So this would become 7 plus 4t equals 0, or 7 minus 4t equals 0. And then we just solve. So I would subtract 7 from both sides to get 4t equals negative 7, which means t equals negative 7/4. And over here, I would subtract the 7 to get negative 4t equals negative 7. And when I divide by negative 4, I'm going to get t equals 7/4. Now I'm hoping right away we can see that there is a little bit of a problem with one of those. I can't have the bird drop the ball negative seconds. So because of that, we're going to basically cancel this one out. You can't drop it negative 7/4 seconds after it takes off. So basically our answer is going to be that it's going to hit the tree, which is 32 feet off the ground, at 1 3/4 or 7/4 seconds. So those are the perfect square pattern and also the dots pattern, the special products. Again, as we said back in the section we worked on these, if you don't see them, you can still use FOIL if you were putting them together. And in this case, you could still just use our regular factoring ways. Find your factor pairs to figure out what the two binomials look like. But if you can see the patterns, it obviously would help speed up everything, make your work a little bit more efficient and get things through and a little bit more accomplished. Take a good look at this, try some of these, and if you have any questions, please write to me or ask me in class.